Okay, for section 5, 6, the last section in chapter 5, we're going to look first at the hinge theorem. And what the hinge theorem says is you have two triangles, and if you notice here, two of the sides are congruent. So these sides are both 3 and these sides are both 4. However, the triangles are not congruent because these angles, these included angles, are not the same. So angle A, can you tell, is bigger than angle X? What do you notice then about the sides that are opposite from those angles? Which one's bigger? The one across from the bigger angle. So it's just like that lesson before. The lesson before we were talking about within one triangle. This is two triangles where you have two pairs of congruent sides and the included angle's not the same. So if I were to make this less than 26 degrees, then you could see that the side opposite the smaller angle is shorter. Or if this is more, then the side opposite the larger angle is longer. So kind of like before where we're just looking at the sides opposite the angles, now we're talking about this within two triangles instead of just one. So that's what the hinge theorem says. It says if two sides of a triangle are congruent to two sides in the other triangle, meaning these two are congruent and these two are congruent, and the included angle of the first is greater than the included angle of the second, meaning that 80 is bigger than 60. Then the third side of the first triangle is greater than the third side of the second triangle, meaning the longer side is going to be opposite from the larger angle. You do have to have those congruent sides to start out with, but that's how the questions are going to look. So that's called the hinge theorem. I think of that like being like a hinge, like we just looked at for that last example. You know, it can get bigger, it can get smaller. That's why they call it the hinge theorem. The converse of that is also true. The converse of that says that we have this side greater than 33. So what's going to be the larger angle here? The one across from the 36. So angle M is greater than the measure of angle R. Or I could say back for this one that RT is greater than the length of AC. And for most of the questions, you're just going to be comparing the two things. So putting in like a greater than sign or a less than sign, depending on how it looks. So this would say the third side is greater than the third side in the second, then the included angle is greater than the included angle of the second. So here's the way the questions are mainly going to look. It's going to say compare these given measures. So what it wants you to do is it wants you to say is MR greater than or is MR less than RP. So I'm going to locate both of those in the picture. So here's MR. What angle is MR across from? The 21 degrees. And RP is opposite from the 19. So which one of those two is the bigger segment? MR is the larger segment, so I'm going to say that MR is greater than RP. And you could just kind of rewrite that. MR is greater than RP. That's the way the answer key is going to be, so if you're checking your answers, that'll be the way it's written. Would it also be okay if somebody wanted to say RP is less than MR? Okay, those would say the same thing. This is the way it's going to look in the answer key. So if you want to make it easier to check, write it with the same way that they have these segments written out. Okay. For this one here, I want to compare AD. AD is opposite from which angle? The 38 degrees. And CD is opposite from which angle? The 22. So which one's going to be your larger side? The AD. So I can say that AD is greater than CD. And again, just comparing which one's which. Okay, for this next one, it wants me to compare angle C. Because it's the angle, I need to look to the side opposite it. So the side opposite from angle C is 48 degrees. And the side opposite from angle Z is 50. I think I said 48 degrees. It's just 48. So which one of those angles is the bigger angle? Angle Z. So angle Z is the bigger angle, so I could say that the measure of angle C is less than the measure of angle Z. And then lastly, for these examples, they want me to compare angle XYW. So XYW is this angle here. What side is that angle opposite from? The 28. And the other angle, WYZ, well, that's opposite from the 42. So which one of those is the bigger or smaller angle? The bigger is this second one here. So I could say that the measure of angle XYW is less than the measure of angle WYZ. So we don't have any way of like figuring out how big these angles are. We're just going to compare the two, say which one's greater than, which one's less than the other one. Okay? For this next example here, it would be very, very, very helpful for you to draw out a picture. I think this would be very difficult to do without. It's talking about two groups of snowboarders leave the same base camp. So I'm going to draw a little picture here. This is the base camp. It says group A goes 7.5 miles due west. So you guys all know your directions, right? Never eat shredded wheat. Never eat soggy waffles. Okay? So we are going due west 7.5 miles. And then we're turning 35 degrees north of west. So that's going to be something like this. And we go another 5 miles. Okay? That says the next group, group B, goes due east 7.5 miles, and then turns 40 degrees north of east and goes another 5. So here's the problem, or here's the problem that kids kind of run into sometimes. This is 40 degrees. This one here was 35 degrees. Are those the angles within my triangle? Actually, I need to draw the triangles because the question's asking who's farther away from base camp at this point. So like the shortest distance farther away. Well, I need to find these angles within the triangle to tell which one of these for group A or group B is farther away. How many degrees would this be within this triangle? So we have this straight line. This is 35. How many degrees would this be? 145. You can just subtract that from 180. Those two are a linear pair. How many degrees would this angle be? 140. Again, they're supplementary. They're a linear pair. You can just take it away from 180. So who's farther away at this point? Group A. Group A is the one that's farther away because they're opposite from that larger angle, that 145 degree angle. So having this drawn out is very helpful. Also paying attention to, you're not really looking at the 35 and the 40 degrees. You'd be looking at like the supplement of those for this question here. To explain your reasoning, you could say something like, you know, the hinge theorem says that the distance from across the larger angle would be farther. Something like that. Kind of, yeah. Or maybe you just say like opposite from the larger angle. You know, make just a little note to yourself there. Okay. So before we get into these last two examples, we need to talk about the potential range for angles in a triangle. You cannot have angles in a triangle just be any number. So what's the potential range that angles within a triangle could be? What's like the very smallest an angle could be?
It could be anything above 0.
Anything above 0. You could have a very, very small angle. You know, it could be 1 degree, or it could even be 0.5 degrees, or 0.000, you know. But it has to be more than 0 degrees. But there's also an upper number to that range too, because you can't have an angle in a triangle be like 1,000 degrees, correct? Okay, so what's like the very upper number that it could be? Okay, 178? Because then you'd have 1, 1, and 178? That's a good idea. What if you had like 0.5, 0.5?
Well, it depends on what your other angle is.
Okay, it depends on what the other angles are. I totally agree. And you probably will not have an angle in a triangle be 178. It'll probably be less than that. But it can't be any more than 180. Okay? That would be a very, very weird triangle if you had one angle that was like 179.999999999, okay? But then you could potentially have the other ones be 0.000, you know, you guys get what I'm saying?
Yes.
Okay? It has to be between 0 and 180 degrees, not including either of those two. Okay? What about sides of a triangle? Do sides of a triangle have constraints also?
Yes.
What type of constraint would the side of a triangle have?
The two shortest angles had to be more than
Okay, that would be the angles.
Not angle.
Yep,
Side.
that would be for sides. But if you don't have any of them,
Oh.
like what's just like the general, like you, somebody pick a number that could not be a side of a triangle.
Okay, sure.
You could have a really big triangle.
Negative.
You can't have a negative number and you can't have 0, correct? There really is, I mean, we wouldn't be able to like cut it out if you had sides of 1,000,000 unless they were like 1,000,000 like super teeny tiny little units. Then I guess maybe you could. But do you agree that all of them have to be greater than 0?
Yes.
There's not really an upper number, like at least theoretically. You know, we could have a triangle theoretically of any size, as long as, again, those sides, any two add up to be more than the third, but not given any of them. All you really know is that that angle has, or the side has to be more than 0. So when I'm setting these up, I need to keep this like in the back of my mind so that that might help me give some more constraint to this. So for this one here, it says write an inequality for the range of values of x. So I'm kind of comparing them just like I did in the last section, or the last part. Which one of these sides is going to be the larger side? The 4x minus 10 or the 40? Which one's going to be the larger one? The 4x minus 10. So could I say that 40 is less than 4x minus 10?
Yep.
Okay, I already knew that it had to be more than 0. Here it's just saying that it needs to be more than 40. So I can solve this, or I could have written this the other way. And when I solve this for x, I know that x has to be greater than 12.5. It does not necessarily have to be less than anything because I don't know the length of this side. You guys aren't going to be able to calculate that. So at this point, that's all that you know.
Wait, isn't there a way to like find the size of just like angle and size less than that?
Right, what you could do right here is you could do some work. you don't have the skills right now to do that for this class. Okay? When we get to chapter 8, we'll learn like how to find different angles and find different sides for right triangles and non-right triangles using like the law of sines and cosines.
Okay, yeah, we can go fast.
Okay, but as of like right now, like we're assuming that this would be the range that it would be expecting you to know. Okay? What about this one here? What about these angles? Which one's going to be the bigger angle? The 33 degrees is going to be the bigger angle. So could I say that 3x minus 3 is less than 33? Okay, but kind of going back to this, is there a lower limit for that angle? Yeah, it also needs to be greater than 0. So this angle needs to be between 0 and 33 degrees. Does that make sense? Do you remember solving compound inequalities like this in Algebra 1? No? Okay. What I always did was I think of this kind of as like 3 parts. So instead of just solving an equation with like 2 sides, you could actually use like all 3. So to solve for x, I need to add 3. But I could add 3 to all 3 of those pieces. So this would be 3 is less than 3x, which is less than 36. Does this look a little more familiar now? Yeah. Okay. And then to solve for x, you'd have to divide by 3. But instead of just dividing like 2 sides of this inequality by 3, I'd divide all 3 parts by 3. So I'd say that x is between 1 and 12. So an acceptable range for that number would be more than 1, less than 12. We don't really have the information right now to find out anything else about that. Okay? Problems or questions on that? Okay, so you guys have time today.